Yeah, so it'd be 5.891.
Hold on. Let me look at my numbers. Let's come back here, let's do stat edit. 4567.198.198. Oh, bleh, bleh, bleh. 0.385. Stat calc, one bar stats. I was off by 5 thousandths of a point. Does that look better?
It's perfect.
Perfect now. Sorry. I left a 5 off right there. Now, it said interpret. What does that mean in standard deviation mean? If I was drawing a normal distribution, where would the mean go? In the middle,
Here, the hump.
in the hump. What does the standard deviation tell us? To the left, to the left, to the left, to the right, to the right, to the right. So if I was interpreting this, my mean would be 5.79, and off of that mean, I would jump 1.15. So my mean is in the middle, and then my standard deviation is what I wiggle off that mean. And I would do like 3 to the left and 3 to the right. Yay? Coming back to us? Now, down here is the pretty version of what I did. There's my frequency, so I did my probability distribution, which was the 17, was it 87? I did the whole thing with 8. It is supposed to be 91. 91. My minimum's 4, my maximum's 8. There we go. And then we went, is it 5.8 and 1.15? I'm going to put 5.79 because that's what I used above. Yay? All right, last page of 6.1. Here is, it's kind of like a histogram. It just doesn't have the bars. It has lines instead of the bars. This says it is a discrete probability distribution. So instead of, because it could have looked like this is going to be rooms because this is your X. This is probability because this is your Y. So it's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 0.009, 0.017, 0.217, 0.391, 0.198. They're just showing you it as a different display. So normally we've been seeing probability distributions like this. This is the number of rooms rented in housing units. So one room was rented by 0.9 people, because if I whoop that, it's 0.9. 2 rooms are rented by 1.7. 3 rooms are 21.7. Y'all with me? They just put it in a graphic format. So 1 room is the 0.009. 2 rooms is the 0.0017. We just wrote it in a different format. So all of these have to add up to what? 1. Because those are going to be my probabilities. So my first question, what is the probability? And we're going to use those numbers because this is a probability distribution. So they're telling me that these are already probabilities. What is the probability that a randomly selected rental unit has 5 rooms?
198.
True that? 5 rooms, 0.198. Now, what got y'all on the test is if I gave you one and I said 0, 1, 2, 3, 4, 5, and then over here I did frequency. And I came up with bars and 2, 3, 4, 5, 6, 9, whatever. And if I would have said the probability of 5, y'all told me 9. This is frequency. So it would be 9 over the total. See the difference? All right, let's look at the next one. Oh, get my lampshade for my cheaters that like to look. Okay, that's super small.
Ain't cheating if you're the one that showed it.
I know. I'm helping you achieve. Just a little bit. Okay, what is the probability that you are renting 5 or 6 rooms? I know you may or may not be able to see the numbers, but how are we going to get 5 or 6 rooms? What are we going to look at?
Add 5 or 6.
Add up the 5 and the 6. This is 0.198, this is 0.103. So we're going to add up the 5 and add up the 6. So 0.198 is your 5, 0.103 is your 6, and that's going to give you your probability of either one. 0.301. 7 or more. 7 or more. What would I do for that one? 7, 8, and 9. So I would add up that one, and that one. So 0.039, 0.018, 0.008. That's your 7, your 8, and your 9. And then I have it written pretty there. And then, now for this one, when it says how many rooms would you expect to have, when you see expect, that means they want to know the mean. They want to know the average. So if I say, what would y'all expect to make on the first test? If we got a new student in class, what would we expect them to make? I'm going to average up all your grades on the first test, and that should be what we should expect them to make, the average of the class. So if I'm going to do an expectation, I'm going to get the averages. So the easiest way to do this, though, I know I got it small. The easiest way to do this is to remember you've got to have it in a probability distribution with your two lists, which means if I were you, ouch. Let me get my camera so I don't steal anything that I'm not supposed to be stealing. I would take that chart and write it like this. And some of y'all can do this in your head. But let me pull that down. I would take that graph and turn it into this so that I easily can see what is my L1, what is my L2. So at 1, I'm a .009. At 2, I'm a .017. At 3, I'm a .217. So that I can easily see what is my L1, what is my L2. And I am going to do stat edit. This is going to be my L1, this is going to be my L2. Then I'm going to do stat calc, 1 var stats, and I'm going to do my L1, L2, and all I'm going to be looking for is my mean. And down here I actually have it written even bigger. So there's all my data, my L1 and my L2. And then I'm going to do, I don't need to look at the window, I don't need to draw a histogram because they already gave me the graph. The only thing I'm looking for is that mean. And this is the same thing as my X bar. And we're going to do that. What's telling me to do that is the word expect. Expect means that you're trying to find that mean. Good? Questions? All right, let me save this one. And then, come on. I will tell you, where did my 6/3 go? Pull up the other one real quick. 6/2. I will tell you for this last section, there's a part that you're going to have to memorize. This section is easy as long as you memorize a certain piece. This is 6.2. It's called binomial probability distribution. Two things that, in the beginning, you got to realize that either you have a success, which is probability, or P, and you have the failure, which is 1 minus P. And we've been dealing with this all along. If 20% are pregnant, then 1 minus 20 or 80% are not pregnant. So you have successes and you have failures. Your failures are going to be your 1 minus P. Your successes are your P's. Your failures are your 1 minus P's. Successes are your P's. Failures are your 1 minus P's.
And that's what we have to memorize?
No, well, we ain't got to memorize that.
Okay. I was like, that's good, I can
Yeah.
do that.
This is like the part that you should already know. And this is not the memorize either, but these are things that you have to know. X represents the number of trials. N is your sample size. And we just talked about these. P is your success. 1 minus P is your failure. X is the number of trials. N is your sample size. I asked 25 people. That's your sample size. P is your success, and 1 minus P is your failure. This is what the different letters mean for right now. So when we do the problem, we're going to be doing N, P, and X for the majority of the problems. We're going to be doing N, P, and X. So sample size goes first, success goes second, and then number of trials goes last. Now, when you're doing success, it is going to be the percent as a decimal. So if I tell you 85%, you're going to do 0.85. Example, 85%, you're going to use 0.85. We're always going to use the decimal equivalent. We never use percentages when we plug in. So we're going to do sample size first. The percent's going to be in the middle as a decimal, and then finally the number of trials is going to be at the end. NPX. A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P. They're in alphabetical order. That's another way we can remember it. A, ABC order. We haven't got to the memorization part yet. All right, we're going to be using binomial PDF and binomial CDF. They say A and O. Mine are A and B. Let me look on my calculator in here. I call it second vars. Here's your vars button. It has DISTR distributive above it. I call it second vars, but you're getting to the distributive. Second vars, and you've got to go all the way down. Oh, they are A and B. My calculator upstairs was, or mine's A and B. What are y'all's?
How did you get there again?
I did second vars.
Second bar. Oh, okay, I see.
I did second, and then I hit vars. Mine are A and B. Is anybody else's 0 and A? Or yours A and B? What are y'all's? Like, your binomial PDF, what is it beside? Mine's A and B too. I was like,
Mine's 0 and A.
Mine's 0 and
Okay.
We're both on
Mine is
83s.
0,
Yeah,
A, B.
it's 83 versus 84.
Okay. Because when I was using mine upstairs, so it may be 0 and A, or it may be A and B, and I don't know what it is over there, but they're right there together. We cool? So we're going to be using binomial PDF, and we're going to be using binomial CDF.
Oh, yeah, that's 0 and A.
Okay, so 0 and A or A and B according to which brand of calculator, and which brand of calculator, and the one that you use in here may be different than the one you use over there, but they're going to be right there together. So we're either going to be using PDF or we're going to be using CDF. PDF is going to be used if it's exactly, if it's an equal. CDF is going to be used for everything else. It's going to be used for inequalities, greater than, less than, greater than, equal to, less than, equal to. And then for both of them, we're going to enter N, P, and X. The sample size, the probability, or the percentages, and then the X, the number of trials. We're going to do lots of these. As long as we have it memorized, we're good. All right. Now, a lot of people get confused with like the phrases, what does less than mean besides less than? So, down here, I wrote some phrases of other things that mean greater than or equal to. So y'all, if you're going from left to right, you get to the big side of the mouth first, because if this is like Pac-Man, this is the big side of the mouth, so this is the greater than symbol, greater than or equal to. So these are words that mean greater than or equal to. If somebody says, I have at least $5, if I have no less than $5, those mean you're using this symbol. More than, greater than, fewer than, less than, no more than, or at most. And I always have to say, if I have at most $5 in my pocket, what does that mean? I've got $5 or less. So I have to put it in my mind as I have at most $5, so that means I can have $5 or less. So that's a less than or equal to. But these are all terms that mean that symbol.
That's the memorizing part you're talking about.
Not yet.
Oh, man.
Well, all of this is kind of, all of this you're going to have to know. You're going to have to understand. And when I was talking to the tutors the other day, they said this is one of the yuckiest sections, just in the fact that you've just got to know the terminology and the vocabulary. And then this exactly is equals. And this is one of those sections that when you get there on the test, I would write out whatever you need to write out before you open the test. Just dump your brain onto the form, onto the scratch paper. Like this one is, greater than, more than, that one's not that bad. These two, you may need to write those down. All right. Here it comes. This is what you need to memorize. And make sure you write it down correctly. The only one that's a PDF is the last one, the equal. So if it's equal, it's a PDF. All the other ones are CDF. So if it's greater than, it's 1 minus the CDF. If it's greater than or equal to, you're going to do x minus 1 and 1 minus the CDF. If it's less than, you're going to do x minus 1 and just the CDF. If it's less than or equal to, you're just going to do the CDF. And if it's equal to, you're just going to do the PDF. I'll give you a second to write those down. Probably not a good day to miss. All right, Courtney is here, Paige is here, Rachel is here, James is here, PJ is here, Myers is not, Travis is here, Josh is here, Barrett is here, Nautica is not, Rebecca is not, Austin is here, Sharon is here, Zalea is not, DeQuasia is here. 1, 2, 3. 6, 7, 8, 9, 10, 11, 2, 4, 5, 6, 7, 8, 9, 10, 11. So, however we can memorize this, and I'm going to let you write it down and I'm going to go over a couple of ways to kind of help you memorize it.
That symbol between greater than or equal to or less than is that an and symbol or a or?
This is an and symbol,
Okay.
and
So you do both of them?
you do both of them.
So it has 2 answers?
No,
Okay.
you just got 2 things to do to get the answer.
So you do x minus 1 first and then do that?
Yep. And the process is not that hard. It's actually kind of a fun process, if you want to call it fun. It's a fun process. You just got to know these rules. You just got to have this cheat sheet. So as soon as you get on the test, you just got to write this out. So, here's kind of like my method to doing this. It's like, you're always great. So I start greater, greater than, equal to, less than, equal to. So like there's my pattern. Greater than, equal to. Less than, equal to. And then finally equal to. Y'all with me? Then I do 1 minus. And then this has both of them. And then this takes away the minus. And this takes away everything. So it's a 1 minus. And then this has both rules, and then we take away that rule, and then we take away both rules. And then you have your equals is your PDF. All of these are your CDF. Okay, so I'm gonna keep those rules up for the first few, and then I'm gonna take the rules down and you're just gonna have to practice writing those rules. All right, now here's your last two rules, but the good thing is, don't stress on me. This is on your formula sheet. Let me pull up your formula sheet for just a second, just to show you how it's written, so that you can be able to find it. Page, hold on. I'll pull it back up in just a second. Let me get to your formula sheet. Course formula sheet. Formula sheet. And what I may do is pull up 5 and 6 so that you can, all right, here is sin. Oops, I forgot that good. This page again. Put those on one page so that we can. Move that over. Move that over. All right, let me let you copy those down, and then I'm gonna show you where it is in the formula sheet. These you don't have to memorize, but they are on the formula sheet. You just gotta know where to find them. The mean is n times p. The standard deviation is the square root of n times p parentheses 1 minus p. So it's the sample size times the p, and this one are the successes, and this one is sample size times the successes times the failures. The mean is sample size times the successes, and standard deviation is sample size times success times failures, and then take the square root of it. I promise these are not as bad as they look. You just have to know what to use. All right, so just so that you can see what all you have out here to utilize on your formula sheet. I have it listed by chapters. So this just says what makes me happy over total. We've got a lot. We've got the or stuff. We've got the and stuff. We've got the complement, which is the 1 minus. This is the given, the probability that somebody's wearing glasses given that they're a boy. We've got the factorial. I would not even use this. I would just use the NPR and the NCR and the calculator, even though you've got a formula for that. Then, what we just did is right here. And that's really the only formula that I'm using out of this. I'm really not using anything else down there except for that formula in chapter 6. Okay? Alright, so that is the formula for the mean and the standard deviation. That's the only one that I'm using. So, let me cover up again. Be super fast. So when you're doing binomial probability, what you have to look for is your x. Is my x greater than, equal to, less than, equal to, or equal to? It is equal to. So, right here, x is equal to. That means I'm choosing the last one. And remember, in the parentheses, they were in order, so it's n, p, and x. So we're going to do the binomial PDF of 15.85 and 12. So I go to my calculator, I do second vars, I go down, 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 down until I get to the normal PDF. It was either A and B or 0 and A. I'm gonna go to the normal PDF, and I'm gonna do 15, comma, 0.85, comma, 12. There's my answer.